So now it's okay, I think. Hello, people. My name is Cauã, and I will present about our work, democratizing AI, making geotechnology accessible to all. Here it's our team. We are from Zeta Agents. It's an innovation agency of Federal University of Lavas, and who worked in this paper is Tomás, Gabriel, Igor, Lucas, me, João, and Sarita. So everyone knows that geospatial technologies have some challenges to reach regular people or people that don't have any technical skills in GIS, and it can be a barrier to access this kind of data, and can't use this data, and some stakeholders that don't know this kind of how to work with this data can face some decision obstacles, and the processes can be inefficient. So we thought that if we try to integrate the AI and the geotechnology, it could be a way to reach this to get small this gap, and so we know that the geospatial data have some can help with some analytics. And sorry, sorry. So what we did, we integrate the natural language process with a prompt, so the user can write the answer, and if the system had the context and and the user used the right question, it can show the results in the screen. So about the development, we create a system with 4 modules. The first one is the graphical user interface using React, an API to communicate the interface with the Gemini AI and the geographic database. We use it to the Gemini AI because we already had some experience using this AI, and it could do what we wanted that have to do. And in the geographic database was implemented in Postgres and PostGIS. So the workflow of the systems, it's simple. It's a simple system. It's just the first steps using the AI and how it can help this kind of users. And so first, the user can write the question in a prompt, and the interface sends it to the API, and the API sends it to Gemini. The Gemini processes the questions, and if the answer is just a textual answer, it already put it in the interface, and if it's a query, it transform it in SQL query and search it in the database, and if it has some geometry, it transforms in GeoJSON and put it in the interface. If it's not, it's put just the table or just the textual information in the interface. So we had to prepare the system. First, we did the environment configuration, the prompt definition, input processing, response management, database integration, geographic handling, data handling, because some data, if you want the AI response properly, you need to have a good context. You have to train your AI to give you the right answer. And handling with some errors and exception, nothing different in any coding. And some performance optimization. So we use it in this work 20 tables and 16 from National Water Agency, 3 from Brazilian Institute of Geography and Statistics, and 1 in the of energy research company. So what we had to do and why we choose these tables. It's because we had to have two. We needed to have good data with good metadata, so, with good information about the fields, about every field in the table. So and the data had to be public information too. And so what? So the tables that have some these conditions were these tables. So we did a method to evaluate if the AI and the response is okay. So we formulate 192 questions, varying complexity levels to simulate different user profiles, from novice to experts. And the result, the statistics results were 87% of these 192 questions were correct and 13 unsatisfactory. And we had 3 types of errors: mismatch errors, lexical errors, and syntax errors. The mismatch ones were where the issues had issues with data compatibility. The lexical ones were where we had misinterpretation of terms, and syntax errors were when we had incorrect SQL structure. Overall, accuracy rate was 87%, but the objective, it's not only evaluate if the AI is okay, if we can use it, but it's just the first steps for something greater or something that can be used for, by someone that don't know the peculiarity of the GIS science or the GIS technology. So about the errors, 64% was mismatch error, 32% lexical errors, and 4% syntax errors. So here we put some examples of the system. First, the user interface. We put a chat in the left side where the person, the user, can write the question, and it shows in the interactive map where you can change the colors, you can change the transparency, everything in the interactive map. And a dynamic table. If you click in any data that you want to highlight, it is shown in the map. So some examples. Here it's I question. I want to see the municipality of Belém in the state of Pará, and it shows in the map. Now the waterways of this Pará state. And another example is hydroelectric plants in San Francisco River. So it put the points in the place, and if I click in the table, it do a zoom to feature. And if the answer is not don't have a geometry, or it's not shown in the map, it can respond to you just with a textual response. And here the example is how many waterways there is in the Lavra city in Minas Gerais. And it responded that it was founded 8 waterways. And here, if you ask something that it's not in the context, or if it's not specific, it responds that you have to be more specific, and it have to be related with all the fields. So the conclusion is the AI and GIS can be integrated. We think it's a good solutions if you put in the right hands. It can be it can be greater and be reached for more people, and put on other tables. If you have tables that have good context, complex contexts, and have more information about the fields, what means if each field, each table, it could be greater. And some challenges that we had in the process is the database standardization to reach the right context to the system, and the AI training itself. You have the key is the context you give to the AI. If you give the right context, you can reach a better results. And the study impact, despite the obstacles, it reached 87% of accuracy. So we think it's we reached what we wanted. It's just first steps for something greater. So here is some future directions. I think where we can go further and think how can we make it better, or how can we make it improve it. So in the AI model itself, you can for example, you can optimize the efficiency. You can expand the database to develop better applications, and the impact and application analysis. We can conduct a study case, different use case for this data or other data, and some ethical and social considerations. We think in the development of this system, we have to ensure data privacy and security, and we have to mitigate algorithmic biases to promote fairness, and design for accessibility across diverse user needs. Thank you, but first I will show the system working. I think it's better than PowerPoint slide.